Okay. Okay then, coming back to the class. So yesterday we have discussed free fall, right? And I told you in free fall, acceleration due to gravity is constant and the value is how much? 9.8. And it is always downwards. Is that fine? Now, there can be a case, for example, when you're throwing the bodies up. So after some time, they'll come back, isn't it? So there are some things that you need to remember. The first thing yesterday I already told you was the time taken to go up is equal to the time taken to come, isn't it? And in case of air resistance, then the time taken to come down is much more. Although our mind will say, hey, gravity is attracting it, it should come quickly, but that is not the case. What is happening is there is some buoyant force there is some air resistance to the body due to which it takes much more time. Is that clear? Yes, very good. Now, see, there's a guy, he's already standing on some platform and he throws the ball up, okay? So his time starts now, okay? His time starts now. So, for example, he throws the ball with velocity u, okay? Now, when the body is going up, at the topmost point, you should remember, this is the maximum height, but at this maximum height, the velocity will be what?
0.
Yes, it will be 0. Second important thing, when you are throwing a body upwards, see, understand what does acceleration due to gravity equal to 10 mean? When you are throwing a body up with, for example, 20 meter per second of speed, okay? What is the acceleration? Is it 10 meter per second square? But what do you mean by acceleration? I told you the definition of the acceleration, yes? We discussed the definition of acceleration. Acceleration means the rate at which velocity changes, isn't it? So when you are throwing something up with 20, the acceleration is downwards and it is how much? 10, isn't it?
Yes.
Approximately. So what does that mean? That means in 1 second, your velocity will decrease by 10. Now if you give something 20 meter per second velocity upwards, after first second, what will be the velocity? After second, what will be the velocity? So can you tell me how much time will it take to go to the top? 2 seconds, see? We are not using equations. We are just understanding what is happening. If you give somebody velocity of 50 meter per second upward, what will happen?
40.
First second, it will have only 40. Second,
30.
how much time, after how much time will it get to the top? 5 seconds, see? We are not taking the equations, we are not finding the time and everything. It's simple concept. That is the understanding. Now, another case. When the body is at the top, what is the velocity?
0.
And the moment I leave it, I drop it, okay? When I drop it, after first second, its speed will be, 10, yeah? And then it will go on increasing, is that clear? Because that is the concept of acceleration. The velocity will increase by 10 meter per second when it is going downwards per second. Is that clear? The velocity will decrease by 10 meter per second when it is going upwards per second. Is that clear? And one more important thing. The velocity is at the same height. The velocity is at the same height from the ground. For example, see, I'm throwing this ball up. When it goes up, during its rise, if for example it is at this height, the velocity was v. So when it comes back at this point, at the same height, it has to go down, isn't it? At this point, the velocity will again be v, but the direction will be opposite. Is that clear? So that means, if for example I'm talking about this height, which is height h above the ground, okay, at this height above the ground, I throw the ball with u. So at this point, say this point is a, the velocity is va, and what will be the direction? Upwards, isn't it? Because it still wants to go up. So when it reaches the top, velocity will be what? 0. But then when it is coming back, and it will come back to point B, okay, at this point the velocity will be downwards and the velocity which is downwards will be VV, isn't it?
Yes.
But you need to remember the magnitude of speeds at A and B will be same. Is that clear? Is that clear? So that means, now understand, if you're throwing something with 20 meters per second upwards, what will happen? 10, 0, 10, 20. So at the same heights, the velocities will be same. So that means if you're throwing something with 100 kilometers, when it comes back, hits the ground, it will again be coming. The velocity before hitting the ground will again be 100. Is that clear? Is it clear?
Yes.
So this is something that you need to understand. Okay, when the object returns to the same height at which it was thrown upwards, the velocity is equal and opposite to the original velocity. It will be equal in magnitude but opposite in direction. Is that clear?
Yes.
No doubt?
No.
Okay. Now let us try to solve questions. The first question is, a football is thrown upwards with velocity v. Okay? I cannot even kick today because tandoor. Okay. So a football is thrown up with velocity v. Do you watch football? How many of you play football? You don't play football. Okay, there's a football. Say for example, this is the ground, this is the football, you're throwing it up with velocity. Is that fine?
Yeah.
What is the question?
Maximum.
Calculate the maximum height. So when you throw it up, tell me if it reaches this point, what will be the velocity at the top?
0.
Very good, the velocity here. The final velocity will be
0.
very good. So the height that it covers, let it be h. Okay? Now try to solve it. Try to solve it, yes. What you don't have? Initial, there is initial velocity. Final velocity is 0. So we have an equation, if you remember, final velocity square minus initial velocity square is equal to, yes, 2 times acceleration times delta x, isn't it? Yes? What is the final velocity? 0. What is the initial velocity? So should I write negative v square is equal to 2 times. Now tell me, what is acceleration? We have acceleration. Under gravity, acceleration is always downwards. It is g. When the body is going up or it is coming down, acceleration is always g. Always. Okay? So what do I write? No, I write negative g. Because the up is positive. Because you're throwing the body up. So you take v as positive, right? If v is positive, then h is positive, but g is negative. Understood? Okay. So delta x will be positive and it will be delta. It will be height, right? Is that clear? So negative and negative cancels out. So you are having height as v square divided by 2g. This is the height. So that means if you give some body 10 meter per second speed, what is the height that it will attain? Yes? If you throw somebody up with 10 meter per second, so what is the height that it will attain? 10 square is 100. 100 divided by 20. Isn't it? 5 meters. Isn't it? If you give a body 10 meter per second speed, after how much time will it be at the top? If you throw a body with 10 meter per second up,
1 second.
exactly 1 second. So can I say in 1 second, in the first second, body can only travel 5 meters? Yes?
1 second is 10 meters.
How? No. That is the change. But acceleration here, see what is happening. The body is going up and then it is coming down, isn't it? So for example, it is at the last 1 second is left. Last 1 second. So the distance that the body will cover in that 1 second will always be 4.9 meters or nearly 5 meters. See what is happening? If I give a velocity of 10, so after 1 second it will be at the top, isn't it?
Yes.
It will take only 1 second to reach the topmost point. If I give 10 meters speed, okay, 10 meters per second, so after 1 second it will be at the top, isn't it? Because it will be 0. It won't go up. So 1 second means it will be at the top.
Yes.
So in 1 second, what is the height that it has covered? The height will be 100 divided by 20. That is how much? 5 meters. So it only covers 5 meters in the last second of motion. Last second. That means if you are throwing any body up with any speed, when it is just below the top and you have only 1 second left. So for example, you give 50. Okay, after how much time will it be at the top? If you give 50 here, 50. Yes, very good. If you give 50, it will be here at the top after 5 seconds, isn't it? For example, 4 seconds have passed. 4 seconds have? What is the speed left at this point? Very good, 10. So can I say the last second, in the last second it has only 10 meters per second speed? Isn't it? The distance traveled will again be 5 meters. So in the last second of motion, every body, for example, there is one body, 10, 20, 30, 40, 50, in the last second before they reach the top, the distance they will cover will always be 5 meters. Is it clear? You don't need to solve this question as well. Clear? Any doubt in this? So tell me, when it will come back, in the first second, how much will it travel again? Again, yeah, it will travel 5 meters. And what will be the speed here? It will be 10. Very good. Is it clear? This is the concept of gravity. Okay, one more part. Calculate the time the thing takes to reach the top. So tell me, if I give 50, after how much time will it be at the top? How did you find it? Yeah, you divide it by 10. So when I give V, what will be the time? V divided by 10. And 10 is what? G. Isn't it? So yeah, in short, I can directly come up with the concept that time is equal to whatever velocity you give, divide that by. You, for example, you give 20. You say, sir, after 2 seconds it will be at the top. How? 20 divided by 10. Is it 2? Yeah. But you need to evaluate it with the help of equations. So what will we do? We know that V is equal to U plus AT, isn't it? So what is the final velocity? What is the initial velocity? V in the previous question, right? So plus, what is acceleration? Negative G, isn't it? Is equal to time. Fine. So this will shift. So we can say that, which implies GT is equal to V, and therefore V upon G will give you the time. Is that clear? We did it with the help of equations, but you had already understood it by the concept. Clear? Any doubt? Okay, one more question. How long is the thing in air? What do you mean by how long is the thing in air? The total time, yes. So that means you throw it up, it takes some time, and then it comes back. So the total, it will be exactly, the total time will be 2 times V upon G. Is that clear? Why? Because I told you yesterday, if there is no air resistance, then the time for up is equal to the time for coming down. Is that fine? Very good. Now tell me, What will be the speed when with which it will strike the ground?
0.
With which speed did I throw it up? No, 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 in this case. No, in this case. We are solving for this question. I was giving examples of 10, 20, 50. But here, V, you throw it with V. You throw it with V. So when it comes back, it will be V. Is that clear? Yes, very good. So it will come back with V. Because at what will be the reason? At same heights, velocity is same. But direction is opposite. Is that clear?
Yes.
Okay, very good. Now, can anyone solve this question? Try to solve this question. So he's saying you have to choose the coordinate system. Coordinate system means you have to decide whether up is positive or down is positive. So a baseball is thrown upwards with the initial speed of 35. What is its velocity after 2 seconds? Can anyone tell me? It is 35 meters per second. 17.5? The question is, a baseball is thrown upwards with initial speed of 35 meters per second, isn't it?
Yes.
What is its velocity at t equal to 2 seconds? After 2 seconds, what will be its velocity? Try to solve it with the equations. Then I'll teach you the concept.
Is it right?
What is the initial velocity? So in this case, what is positive? Up is positive. So try to solve it for up first. The value will not change, just that the sign will change. Negative? Negative what? 19. Okay. Anyone else? Negative 15. Anyone else? Yes, Tagreed? You don't want Costa coffee today? $8.75. Okay, anyone else? Yes, Khalifa? Do it, come on. We know the kinematic equations, right? So try use them. So in the first case, okay, I'll show the first case. He's saying that up is positive. Up is positive means he's throwing it up with 35 meters per second, isn't it?
Yes.
So acceleration is downwards. Correct? Yes. So what is the question? We have to find the velocity after 2 seconds. So time is given. Time is given. So after that, velocity final has to be found, isn't it? If up is positive, then initial velocity has to be taken as plus 35, isn't it? And if up is positive, then g, acceleration, is taken as? Is that fine? For questions, you can take it as 10 to ease your values, okay, calculations. Now, let us try to solve it. Which equation will we use? V final? Yes. V final is equal to V initial plus acceleration into time. Is that fine? So, what is the final velocity? We have to find that. What is the initial? 35. Plus, what is the acceleration? Negative 10. And what is time? See? 35 minus 20. How much is it? If you are smart enough, you don't need to solve it. I just told you, if the velocity is 20, after 1 second, after 2 seconds, you told it, isn't it? If I give 50, after 1 second, and then Because per second the velocity will decrease by 10, isn't it?
Yes.
What was the speed?
35.
After how many seconds we have to calculate? So 35 after 1 second will become 25. After second it will become 15. Do you get it?
Yes.
We don't need equations if you understand what is happening. But equations because we have to show the examiner what we did. But in reality we have to understand. If it was 35, after first second it will reduce by 10. That means we'll be only left with 25. And then when we again take it for one more second, it will reduce again by 10. It will be 15. That's it. But what is the difference between up positive and down positive? See, when the up is positive, the velocity is decreasing, isn't it? But it is still positive. The body is still up. Is that fine? So the answer comes out to be positive. But when down is positive, now try to tell me the answer when down is positive. It will be negative 15. Is that okay? Because time is again the same. Final velocity we have to find. Initial velocity will be taken as negative 35. And acceleration will be taken as plus. And therefore, the expression will be, for this case, the answer would be negative 15. Is that clear? Do you understand it? Do you have any difficulty? Hiba, solve this question. So this question I had asked in the first assessment test. Now today I hope you don't do any mistake. Understand the question and then tell me what we are going to do. This was asked in the assessment paper, okay? So now try to solve this question. A package falls of a freight elevator that is ascending at 12 meters per second, okay? There is an elevator, for example. Okay? This elevator is going up with 12 meters per second speed. And there is this package, it falls. Okay? What? Yeah, the question is, the package is 22 meters off the ground. So, from the ground, if this is the ground, this height already is how much? 22 meters, okay? Up to this point. Okay? This is the information given to you. Now, what is the question? The question is, how long will it take the package to reach its maximum height? Yes? How long? So we have to calculate the time which will take the elevator to its maximum height. Yes? You are up?
Isn't it 0? Because when it starts falling, so it starts at
Just tell me, yeah? You have to understand. I'll redraw the diagram. I will redraw the diagram. Maybe here, okay? So this is the package. It falls off. It was going up with a speed of 12 meters per second. The height from the ground is 22 meters. The question is, how long will this package take, because it falls, how long will this package take to reach its maximum height? It's already at maximum. Anyone else? 1.2 seconds. 2.2. Anyone else?
falls, so it just drops off. Right?
The diagram was shown.
1.8.
1.8. Yes. Yes, Tagri? See, understand. When something is going up, everything which is present over this is also going up, isn't it? Now, all of a sudden, even if it falls, it has momentum, isn't it? Due to which it will still try to go up. So, it will go up, this package will go up with a speed of 12 meters per second. So, do you know the time that a body will take to go to its maximum? Yeah, I told you, just we solved it. Time is equal to, yes, V over, isn't it? Simple. Yeah, of course. So it will be 12 divided by 10. And that would be what? 1.2 seconds. This is the time after which this package will be at its maximum height. Is that clear? But understand, very important thing, at this point, the velocity will be 0. Good. If I ask you one more question. When it comes back, it will not come to the elevator, right? It will reach what? The ground, isn't it? There will be two questions that we can ask. First, when it reaches the ground, what is its speed? Okay? Another thing, when it reaches this point B, what will be its speed? Yes. And how much time was it in air? Is that clear? Do you understand what I asked? First, when you throw it up, it will go up, it will come down, and it will reach the ground. So at the top, the velocity will be 0. The time this motion takes, the time that this motion takes, this is 1.2 seconds, isn't it? So the question will be, for what time was it in air? What will be the velocity when it touches the ground? What will be the velocity when it was at the same height? Negative 12. Can you solve it? Yes? 33? Let us see. See.
34.
What is the question? So, how long will it take the package to reach its maximum height? What is the time? It is 1.2 seconds. Very good. Second is, how high will the package rise? Yes. How high will the package go? From this point to this point, he is asking us the height, isn't it? Can you tell me the direct expression that we just found? I told you, if you give velocity v, the height that it will attain is v square by 2g. We just solved it, see? We solved it here. If a package has velocity v, if you throw something in air with velocity v, then the height that it will attain will be equal to what? V square divided by 2g, isn't it? We can use this expression directly. Or if you don't want to use it, you can use the concept of kinematic equations. Whatever you want. See, this helps us to do it quickly. Otherwise, you can use the kinematic equation. Is that okay? So, coming back to this question, if you want to solve this second part, how high will the package rise? So, at the top, you know the velocity is 0. You know that the initial velocity is 12 meter per second. You also know the acceleration is equal to negative g. So, if the question is for the height, we have this equation that v final square minus v initial square is equal to twice acceleration times delta x, isn't it? Yes. So we have to find delta x. Final will be 0. Initial is 12, so it is negative 12 square, that is equal to 2 times. Acceleration is negative 10, and delta x is h, isn't it? Yes. So negative will go. So it is again, see, 12 square, which is v square, divided by 2 times 10, 2g. That is the height. Yes, tell me the result. 7.2. So the height is 7.2 meters. Clear? Yes. No doubt in this? Yes. Next, how long will it take for the package to reach the ground? What is he asking in part C? Time. Which time? Exactly, the total time, isn't it? Yeah. So first it will go up, then 2.4 up to this, but then it will take still some more time, isn't it? So better is, what is the better thing? The better thing is, we will calculate the time it takes to come from top to bottom. Okay? If we are able to do that, we will add 1.2 to that. That will give you the total time. Isn't it? See. This is the package. It is going up and then it is coming down. Isn't it? So at this point, what is the velocity? Very good. So this height is known. How much? 7.2. How much time did it take? 1 point? Isn't it? Now tell me. We know that the time taken to go from this point O to T is equal to 1.2 seconds. Isn't it?
Yes.
If we calculate the time to come from top to the ground, whatever time this will be, if we add that time to 1.2, will we get the total time? Yes? So let us calculate this time. How much time it takes from top to G. Okay? So, time to come from T to G. Okay? So here we have initial velocity equal to, isn't it? Because when it is at the top, now it will drop. It's kind of dropping things, isn't it? So that time will be, that velocity will be 0. Clear? What is the total height? What is the total height? This is 22 already. This is 7.2, isn't it? So total is 29.2. Very good. So the total height is 29.2 meters, isn't it? Also, do you know the value of acceleration? 9.8 or 10. Is that fine? Let us try to use the time. What do we have to find? We have to find time. What do we have? We have initial velocity. We do not have final velocity. So when you don't have final velocity, what do? You use an expression. Yes? What is that? Yes, we have an expression.
T equals radical 2 times h
Over G. How did you find it?
We know that this
See, you know that delta x is equal to initial velocity into time, isn't it? Plus half of, yes, acceleration into time square. Do we know this equation?
Yes.
Yeah, we can use it. Now here, this term will be 0. What is delta x? Very good, it is 29.2. That would be equal to, yes, half of, what is acceleration? Multiplied by time squared. Is that fine? So we'll find the time. What will be the time? Yes. Yes, time would be 29.2 multiplied by 2 over 10, and then you take its square root, isn't it? Is that fine? Clear? Evaluate, tell me the time. Yes? 2.4? 2.4 seconds. So this time is the time taken from this point to this point, isn't it?
Yeah.
What is the total time? Yes. Therefore,
Add 1.2.
yeah, very good. So therefore,
8.6.
total time. There is too much lag. Would be, yes, it would be 1.2 plus 2.4, that would be 3.6 seconds. Is it clear?
Yes.
Any doubt? No, the last part. Solve this question here only. What will be the speed when it strikes the ground?
Total the acceleration.
No, speed. 36? No, he's asking us the speed. 8.1. How did you? Yeah, anyone else? 24. Speed. See, the question is, let me go back to the original diagram. 8.1? How many of you say 8.1? 8.1, 8.1, 8.1. You as well? Okay, let me see. See, what is the velocity here? 12. What is the velocity at the top? If he asked you what is the velocity here? Very good, it is 12 again. But he is asking you what is the velocity here, isn't it? What I will do is, initial velocity is, this will be the final. And do you know how much time does it take? Yeah, you know the time. From this point to this point, you know the time, right? No, 2.4, not 3.6. Because from here to here, only 2.4. Total is 3.6. Is that clear? So let us try to evaluate. We're going to find the velocity at the ground, isn't it? Velocity at the ground. So this velocity square minus initial velocity square will be equal to 2 times acceleration times delta x. Is that fine? We have this equation as well, correct? We can use this equation. So the initial velocity is? Very good. So what is the velocity at ground? Yes, it will be equal to square root of 2 times. What is acceleration? What is delta x? What is delta x? Yes, it is the distance from this point to this point, isn't it? We found that. How much is that? Very good. That is 29 point. Tell me the result. 24 meter per second. Is that fine? Clear? 24? 24.6. Hmm? 24.1. Is that okay? Do you understand? Yeah, you said 24. So, do you find free fall difficult? Is it easy? That is it. Nothing else can be asked. Nothing else. It is just that how easy you make the question. Break the question into several steps. Take upward motion separate, take downward motion separate. Is that clear? And if he asked you, see, one more question could have been asked from the same question. How much time does the body take to come from this point to this point? Yes? How much time does the body take to come from this point, say x, to g? 1.2. How? Because total time is how much? 3.6. But while going from this point to this point, we know it is. So this also has to be. So this is 2.4. Therefore, the remaining will be here. Is it fine? That's what you have to do. And one more thing. What is the speed here? 12. Isn't it? And when it reaches this point, the speed is 24. So how much is the change in speed from this point to this point? Nearly 12, isn't it? That is what these types of questions will be asked. Just that you have to evaluate everything from the bits. Okay? Clear? Write down a question. Write down a question. A body, and we will finish. You can solve this question, okay? I'll draw the diagram for you. A body is thrown vertically upwards. A body is thrown vertically upwards with a speed of 40 meters per second. A body is thrown with a speed of, yes, 40 meters per second from the top of a building. from the top of a building. Okay? If the speed on reaching the ground is 90 meters per second, okay? If the speed on reaching the ground is what? Calculate.
What do you want?
I will tell you. Calculate the height of the building. 90. Calculate the height of the tower.
50 meters.
Fine? Do you understand the question? We don't know the height of the building, but from the top there is a body which has been thrown up. With what speed? 40. He is saying when it is coming back on the ground, the speed is 90 meters. Okay?
50 meters gain.
Question is, what is the height?
50 meters gain. The ground.
What is the height?
Five?
Is
Five?
5? Who said it? How?
No, the question is not really happening.
80?
80?
It's 40 feet.
Anyone else?
10. Acceleration.
Yes?
Acceleration is gravity, right?
What? Acceleration is always downwards, and it is g, and you can take it as 10, no problem.
GF equals GI per CT. Take that as negative, right? Negative G.
Depends. If you're taking it upwards, then it is negative. If you're taking it downwards, then it is positive. So I told you, break this into several segments. Is that fine?
Look at time.
So this you can take it as your homework. Okay? Because questions like these will be asked in tomorrow's test. So I gave you one of the glimpse what will be asked. G is equal to 10 meters per second square. Any doubt? Anything you want to ask? Is it clear? So if I want to ask you about your understanding of free fall, where do you rate it? Agreed? Yes? Here?
Yeah.
You can set up, you can solve the problems, but with errors. Okay. 2.5, that means again the same. Yes? Nora? 3. Yes, well, Salma? Salma is not feeling well. 3, Hibba? 2.9. Yes, you there? 2? Khalifa? Where? Can you? Yeah. And what about you, Mueed?
2.5.
2.5. So I think most of you are saying somewhere here, right?
Yes.
You found the result? Let me come back. Okay then, thank you so much. See you on Monday.